Okay, so we're going to draw the Vesper diagram for this molecule. First, we need to know the valence electrons. We have 26. So we're going to draw the Lewis structure. So far we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 electrons now. Okay, so now we're going to draw Vesper. But we need to know the shape. And since we have 3 bonding electrons, and then we have 1 lone pairs, we know that this is a trigonal pyramidal. Okay, so, and in the middle, Cl, wedge, Cl, Cl, oops, and then the lone pairs. And this angle is going to be less than 109.5 degrees. And this is due to the lone pair repulsion is less than bonding pair, I'm sorry, it's higher than bonding pair repulsion. So this is a box diagram, and we're going to find the hybridization of nitrogen, and we're gonna write the electron conformation of nitrogen. So now here we see that we do not need an excited state because we already have 3 lone electrons. So we're gonna go straight to hybridization. So 1, 2, 3, 4, and since we have an S here and a P here, this is going to be called sp3 because we have 3 of them here. And for nitrogen, we are in the 3p section of the electron conformation. 1, 2, 3, 4, 5, and since we have 3 of them, we're going to multiply this by 3. So here we already have 1 done, and we have 3 lone pairs. So for this one, we are going to form a bond, and since we have 3 of them, we're going to fill those 3, and this is called the bonded state. Therefore, this is called the sp3. So using as a reference the Vesper diagram, we're going to draw our contour diagram. And as we said, this is a trigonal pyramidal. Sorry, I don't have a ruler. These are called sp3, so we're gonna label that in each of the 4. Now we're going to draw our CLs, and we're just going to show the bonding. We're not going to show the whole thing because it will be very complicated, but we're just going to show the bonding of Cl and N. And this is going to be called the 3P. Make sure you label these ones Cl, Cl, Cl. Oh, we see we made a mistake here. This one doesn't make a bond, so we're gonna delete this part. I cannot delete, but pretty much this doesn't make a bond, so it's a lone pair. And this is what we call, oops, this is what we call bond pairs. The bond. So the bond here and bond here. And as we said earlier, this is going to be less than 109.5 degrees.